So, the general characteristics of solid was discussed, and types of solid, that is crystalline solid and amorphous solid, and their physical characteristics was also discussed on the last class. Now, today it is the distinction between crystalline and amorphous solid. Very important question is this, distinction between crystalline now and amorphous. Now, from the physical properties of that solid, you can make the distinction about the crystalline and amorphous solid. Okay. Now, one point is that one is isotropy and anisotropy. What is isotropy and anisotropy? It is regarding the position of the points. It is regarding the position of the points. So, anisotropy is found for the crystalline and amorphous is found for the amorphous solid follows isotropy and crystalline solid follow anisotropy. Now, what is about the isotropy and anisotropy? So, when the physical properties such as the electrical conductivity, the thermal conductivity, refractive index in all the direction in space are same, then it is called isotropic, and this property is called as isotropy. On the another side, when these are not same in the space, then it is called as anisotropy. What are these? These are some physical properties such as electrical conductivity, thermal conductivity, mechanical strength, etc. When these are same, that is called isotropy, and when these are not same, then it is called anisotropy. And crystalline solids are anisotropy because of they are making measurement in different direction. The particles that fall on the way are not the same as shown. Suppose we have to draw the figure, then it would be different. Okay, so the crystalline substance and amorphous substance. Now, regarding the physical texture of the crystalline and amorphous solid, there may be difference, they may be differentiated. So, number 1, distinction between crystalline and amorphous. Number 1 is that the crystalline solid have definite and regular arrangement. So, it is the points, position of points. So, the crystalline solid are having definite and regular arrangement, whereas the amorphous solid, they do not have any regular arrangement. Okay. Now, what is about the shape? Now, crystalline solid have definite characteristic shape. So, next is that shape. Crystalline solid have definite arrangement of space. What are these? That is the shape, that is of the octahedral or etc., the hexagonal close packing. These are the different kinds of shape. Number 3 is that these are true solids and these are supercooled liquids or pseudo solid. Number 3 is that state. So, crystalline solid is by the state it is true solid, but the amorphous solid, it is a special state of the substance, that is sometimes it is supercooled, okay, and these are also called pseudo solid. Number 4 is that order of arrangement. So, order of arrangement tells that these having long order arrangement of the particles. That means, suppose if a crystal is like that, then if we continue travel in that direction, not only in the 2 dimension, it may be in the 2 or 3 dimension, we will get a long range order. That means A B, A B, A B, etc. Here also A B, A B, A B. This is called the long range arrangement, but for amorphous solid it is short range. It was discussed on the last class. Next one, nature of physical properties. They are anisotropic crystalline, that is their physical properties are different in different direction. Number 5 is that about physical properties. Physical properties. So, crystalline solids have different physical properties, that the physical properties, the value of the physical properties are different in different direction, but it is same for the amorphous solid in different direction. This is about the physical properties. Number 6 is that melting point, you know about it. The melting point of the crystalline solids are high regarding to the amorphous solid. So, this is the 6th point, and the number 7 is rigidity. It is also known to you the crystalline solid is rigid compared to the amorphous solid because of tough binding forces in between the crystal, that is the constituent of the crystal. And the enthalpy of fusion, which is the enthalpy of fusion for the crystalline solid having a definite enthalpy, but it is not that for the amorphous solid. Enthalpy of fusion, it is definite for the crystalline solid, but it is varied to a range in case of amorphous solid. So, it is these are the points of distinction in between the crystalline and amorphous solid. This is one important question also. So, first point is the position of the points, that is they have the regular arrangement of the constituent particle. I have discussed, that is if A, B, C, A, B, C, A, B, C, this is called the regular arrangement, but it is not that. And if you follow the crystal structure, it is true for the in the 3 dimension space for crystalline one, but it is not that. The arrangement of the points is not that, it is the amorphous solid. And also if you follow the crystal structure, of unit cell, there they will be equidistant from each another. Suppose this is the one crystal is like that, and it should be equidistant from that. The every point should be equidistant, but it is true for crystalline one. But the same kind of structure if you follow, then it would be not a regular arrangement will be shown. Sometimes the bond length or the will be greater, such kind of bond, but they having the same number of points, but there is no continuity in the bond angle. This is true for amorphous solid. Now, the crystalline solid cannot be converted to the amorphous one, but the amorphous solid can be converted to the crystalline one, because the first one, that is the conversion of crystalline to amorphous, is not favorable in case with respect to the Gibbs free energy, but it can be converted, that is the from amorphous solid to crystalline. Next one, shape, it is having regular shape when it is cut by a knife, and we will get a portion which is completing its regular arrangement. Okay. But in case of amorphous, it is not like that. Here a irregular arrangement of the points will be shown when it should be cut by some instrumental methods. Next one, I have written that the state is that, or nature, definite characteristic shape, that is the hexagonal, cubic close packing. Okay. These are also safe, but it is not true for amorphous. Order of arrangement, long range order, that means repetition of the units or repetition of the points takes to a long range, so that we would get the definite arrangement of the points is continued and get a regular shape. This is about the nature or shape. Number is the state. It is anisotropic, that is the physical character, it is having different value in different direction for the physical parameter, that is the refractive index. Okay. So, this is the point of distinction. Now, coming to the next one, that is classification of solids. Classification of crystalline solid. So, this was the classification of solid. Now, crystalline solid. There are 4 types of crystalline solid. What is this? Number 1 is that ionic solid, covalent solid, molecular, ionic solid, covalent solid, molecular solid, and number 4 is that metallic solid. Now, the molecular solid, it can further be divided into 3 parts: non-polar, polar and hydrogen bonded. Non-polar, hydrogen bonded and polar. Now, discuss one by one. So, first one is that ionic solid. Now, such kind of crystalline solid are true for the ionic compounds, the sodium chloride, the potassium chloride, the copper sulphate, the sodium sulphide, etc. These are the crystalline solid, and we can see the definite arrangement because there the forces is Coulombic force of attraction, that is Q1 Q2 by R square, which is involved in between the particles, that is the cations and anions. Okay. So, these are the ionic solid. Now, these are the some example: NaCl, sodium sulphide, potassium chloride, etc. So, you can see that here the 2 kinds of particle, that is cations and anions are there, and if you see one crystal of sodium chloride, there is a regular arrangement, and in between 2 chlorine there is 1 sodium. In between 2 chlorine, just I am drawing one face of that. In between 2 chlorine there is 1 sodium. So, the cross marks indicating the sodium and the round marks indicating the chlorine. And in between these there are 2 sodium. When there is 2 sodium, then here will be 1 chlorine. So, this is only one phase, and if it is continued in 3 dimension, if it is continued up to 3 dimension space, then we will get one crystal of sodium chloride, which is hexagonal in nature. Here also one chlorine, it is one sodium, it is chlorine, here sodium, here will be sodium, here is chlorine, here chlorine, here chlorine, here is one sodium. Okay, here is sodium, here is sodium, here is one chlorine, here chlorine, here will be chlorine, here is sodium. Now, at the lines, it should be straight line. Okay. So, these are the points. So, this is Cl, this is sodium. In caption here would be it is the sodium plus, and the cross it is the chlorine minus, and the cross is Na plus. So, this is the about the ionic crystal. Okay. So, Coulombic interactive force are there, these having close packed arrangement of the crystals, that is the of the cations and anions. These are non-conducting in solid state because the ionic movement is negligible here, but they can easily conduct electricity in case of aqueous solution. You know that the aqueous sodium chloride solution are easily conducting, but the molten sodium chloride also conduct electricity. Ionic solids are generally dissolved in water, it is true, and it is participate in the ionic reactions which takes place in the aqueous solution. These are the physical characteristics of ionic solid. Next one is that about covalent. Now, just remember once the ideas you have used in case of VACPR to detect the shape of the compounds like the BCl3, the PCl5 or SF6. These shapes are a part of covalent solid, because here the covalent bonding is there in between the constituent SF5, SF6 or PCl5 etc. So, when a covalent bonding in between the constituent is there, here no regular arrangement is there, it is the discrete part, but the discrete part behaves as a solid. So, the examples are the covalent molecules. Covalent molecules are the examples here. You can give lots of examples regarding to the covalent solid. Some of these here, the diamond may be, okay, and the silicon carbide, these are covalent solid. PCl5, BCl3, they are poor conductive towards electricity, and these having generally high melting points because of the covalent bonding, because in case of diamond you can see, and sometimes they also conduct electricity. Just for example, the graphite can conduct electricity etc., and sometimes they are very much stronger when a carbon compounds is there. They are also called the network solid. They are also called network solid because just in case of that silicon carbide, if you follow that, a large polyhedron is prepared. Just in case of the Buckminster Fuller, it is also a compound of carbon, but here the covalent bonding is there, which ultimately takes a giant molecule. So, this is also a part of covalent solid, but as it producing a large chain or chain of networks or chain of bonds, then it is also called the network solid. So, when the covalent bond formation mix and a giant shape, that is the C60, C70, then it will be called as a network solid. So, it is the alternate name of the covalent solid. Some characteristics are they are giant molecules, these are hard and also brittle. Network breaks when some stress is applied. So, these are ready to breakage when it depends on the strength of the bond, okay, and also the it is different from that of the crystalline solid. They have high melting and boiling points, are poor conductor of electricity and acts as an insulator. These are about the covalent solid. Next one is the molecular solid. Now, the molecular solid, it have defined it had three types. One is neutral, one is the polar, and sorry, it is not polar, it is the molecular solid. Is the first one is the polar, non-polar, and hydrogen bonded. Hydrogen bonded. So, first of all discuss about what is the polar. So, example is that HCl, NH3, such type of molecules, because there is the electronegativity difference of the constituent atom, then it will be called as the polar molecular solid. Non-polar molecular solid, what is this? First of all, it is the hydrogen, the chlorine, because there is no gap, there is no difference in electronegativity. So, it will be called as a non-polar. And what is hydrogen bonded? The H2O, HF, these are hydrogen bonded, and it is also a part of molecular solid. Okay, now, regarding to that, because they are liquids, but they are assumed to be the molecular solid. So, with respect to these, there is a contradiction may arise that they are liquids in general state, but how they are assumed to be a solid. But here the concept is that because they are thinking here the molecular level is taken into consideration, not as the physical state is taken. As in the molecular level they are solid, and they are like that, the molecular solid. This is the third one, and fourth one is the metallic solid. Metallic solid, here only the metal atoms are there, that is in the structure of any metal, it is only the metal atom. Suppose in a copper, the iron, here only the iron atom or only the copper atom is there. Here it is it having a tough binding because of some forces, which is also called the van der Waals forces, and the valence electrons are there in free state. For this reason they can conduct electricity, and the kind of bonding is called metallic bonding, and it is due to the electronic force. Okay, so for this reason they are tough and having high melting point. What are the characteristics is that with a difference with the ionic solid, it can conduct electricity in its general state, that is in solid state. Its high melting point and large number of valence electron are closely packed in the space. They are generally shining luster and malleable and ductile, but not brittle just like the covalent solid. They are having high tensile strength. So, these are about molecular solid. So, I discussed about 4 types of crystalline solid. One was the first one, that is the ionic solid, then covalent solid, and then molecular solid, and at the last the metallic solid. So, this is the types of solid, and with regard to that I will continue the crystallography on the next class. Clear? So, from that part the important question is that you have to be remember the definition and some examples of that. Okay. So, that is all for today's class, and